This is the video where we're finally going to complete either the notes from your isotopes video or your ions video. The chart on the very back, this is to help us calculate the number of protons, neutrons, and electrons and the mass of an atom. We are going to start by calculating the numbers to fill in the blanks. And as we go, we will talk about how do we find the answers. If you don't catch all of that as we go, at the end of the video, I will post a slide that has that all filled in at once, and you can make sure to double check that you've gotten everything you need written in there. We're going to start with O. The element symbol O stands for oxygen. The table gives us that we have 8 protons. That means oxygen's atomic number must be 8. This also happens to have 8 neutrons. And we need to calculate the number of electrons and the mass of that atom. If we know oxygen has 8 protons, then it must have 8 electrons. This is equal to the number of protons for a neutral atom. The mass of an atom is calculated by adding the number of protons plus the number of neutrons. So 8 protons plus 8 neutrons equals a mass of 16. Remember, these are mass numbers for individual atoms. This is not the average atomic mass that you find posted on a periodic table. The second element we're looking at is Li, lithium. We don't have the number of protons or the number of neutrons here, but we are given the number of electrons and the mass of the atom. Just like with the oxygen, if we know the number of protons, we know the number of electrons. The same is true here. If we know the number of electrons, then we know that it must have the same number of protons. How many neutrons are in this lithium atom? If the mass is 7, and we subtract the 3 masses that we know are protons, whatever's left must be a neutron. So therefore, we have 4 neutrons in this atom of lithium. Notice I'm saying atom and not ion because there is no charge here. So it must be neutral. The third row is a fun element. Hg stands for mercury. Many of the elements have symbols that don't match the spelling of their names. Many of these came from Greek, Latin, other languages, and they've stuck because they were already popular and commonly known. So Hg stands for mercury. Here we don't know the number of protons or electrons, but we do know the number of neutrons and the mass. So if we know there are 200 masses and 120 of those are neutrons, then whatever is left must be a proton. So there are 80 protons. Since there is no charge given with the symbol for mercury, we know that it is a neutral atom and must contain 80 electrons as well. If you haven't already tried, pause the video and try to calculate zirconium, Zr, from the information given. So for the zirconium, we actually have a zirconium with no charge in the 4th row and a zirconium with a 2 positive charge in the fifth row. We're going to start with the fourth, and we see that we're given that it has 40 protons and 51 neutrons. Since this row does not have any charge, we know that it is neutral, and so the number of protons also gives us the number of electrons. The 40 positive protons will cancel out completely with the 40 negative electrons. To find the mass, we know that there are 40 massive particles that are protons, and we know that there are 51 massive particles that are neutrons. So when we add all of those together, by definition, the mass number, 91. Now when we look at the next one, this is the ion, 2 positive ion for zirconium. It has the same number of protons, which we should expect because since it is the same element, it has the same atomic number, the same number of protons. This one also has the same number of neutrons. So these two are not isotopes of each other. And since the number of neutrons doesn't change and the number of protons doesn't change, it's safe to say that the 40 protons plus the 51 neutrons will give us the exact same mass for these two atoms, the atom zirconium and the ion zirconium 2 positive. So the difference must be in the charges. When we're thinking about charges, we have positives, we consider the protons, and we have negatives, so we consider the electrons. Remember, neutrons do not have a charge, so they don't come into account for any of the charges. If you recall from the last video, we used the number of protons minus the charge. So the charge here is 2 positive, and this will give us the number of electrons. If there are 40 positives, there must be 2 fewer negatives. 40 minus 2 gives us 38. Since the number of protons can't change, to get the charge, we have to change the number of electrons. The last two examples in this chart are both the element W, which stands for tungsten. It's another one of those not matching symbols and element names. But we have here, if you remember from 2 videos ago, this is tungsten 186 and tungsten 181. That means that the first one has a mass of 186 and the second has a mass of 181. Again, not surprising, they have the same atomic number, the same number of protons, 74. Since they are isotopes of each other, we know that the masses are different, and the neutrons then must be different. The number of electrons, however, since they are not ions, we have no charge given for either of these atoms, then the number of electrons should match as well, and they should match the atomic number, the number of protons, because they are neutrally charged atoms. So how do we calculate the number of neutrons? Just like we did for lithium in row 2, we use the mass, 186, minus what we know to be protons, 74. And when we do the math, we get 112 neutrons. For tungsten 181, predict how many neutrons this one will have, since we know its more massive brother has a higher mass. Tungsten 186 has 5 more masses than 181. Since they have the same number of protons, 74, then it is not a surprise that when you do the math, it also has 5 fewer neutrons. So as we've gone through, we've discussed how we find these numbers. The slide here shows both the answers that we calculated throughout this video, and in the bottom section it includes all the different ways that we have learned so far in order to calculate those numbers, depending on what information we are given. The information we are given can come from a periodic table, it can come from the symbol, it can come from the name, or it can come from a word problem or a chart that already has information filled in. Make sure that you copy all of the ways, and also noted in the bottom of each column in blue is the information about the changes that are possible for each number of particles. The number of protons doesn't change for a given element. We know that it can, but that's a very, very, very rare event, so for this course we're going to say that it doesn't. The number of neutrons changes based on the isotope mass. Again, we get that information from either an atomic symbol or an isotope name. The number of electrons changes based on the ionic charge, whether the atom has gained or lost electrons, whether it has become positively charged or negatively charged. And the mass number of the atom changes based on the isotope mass, or the mass number of the atom, and it also changes with the number of neutrons. Feel free to go back through this video as many times as you need in order to help when you are doing the calculations problems with finding the number of protons, neutrons, electrons, and the mass number of atoms.